This is a coffee cup calorimeter problem involving a reaction. And it's one of the two types that we're dealing with. It says the dissolving of ammonium nitrate is used in chemical cold packs. If 33.7 grams of ammonium nitrate is dissolved in 88.9 milliliters of water at 20.6 degrees Celsius, what is the final temperature of the solution? It says the mass of the solution, hint, mass of the solution is the mass of the salt and the water together. Which maybe you knew that, maybe you didn't, but we'll say that. All right, so the basic equation for this is Q sub reaction equals minus Q sub solution, where there will be a reaction. That's relatively clear because there is a reaction in the problem statement, and I give you the delta H for that. And so I know this is our first time looking at delta H, and so delta H is the change in enthalpy upon reaction, and this reaction just happens to be a dissolving reaction. But enthalpy is kind of a weird word, and so when I hear the word enthalpy, I think heat energy. So the working definition of delta H dissolving is going to be change in heat energy due to dissolving. That's what I'm interpreting this here to be. And the sign of this is positive, and we'll talk more about this for next week's homework, but with 25.7, so positive sign, so delta H greater than 0 means heat goes into this reaction. Okay. And I don't know if you've ever used a chemical cold back before. Again, so soccer is life, I guess some people would say. But my experience with chemical cold backs was soccer. So you would have them on the sideline and you would squeeze them. And when you squeeze them, you actually mix the salts, the ionic compounds, the salt, and the water, and then you shake them a little bit, and it causes the salt to dissolve. And as it dissolves, it gets cold enough to keep your sprained ankle from blowing up. That's my experience of it anyway. Teachers I should know better than the slide tackle, but sometimes you just got to do it. Anywho, so now back to this process. So the solution is changing temperature. And so whenever it changes temperature, it's going to be this term, mass times specific heat times delta T, which is just like the previous problem that we worked with two materials. I'll put in my minus sign because I don't want to forget it. But what's new is this Q reaction term. And that's going to be delta H reaction, which in this case is delta H dissolving. Times moles dissolved, in this case. But usually it's just going to say moles reacted there. But this is a dissolving reaction. Okay, so now one thing to point out, at least one thing to point out, our specific heat capacity, if you'll remember, is 4.184 joules per gram degree Celsius. Our delta H will always be given to us, or just about always, in kilojoules per mole. And it doesn't matter how you work this problem out, but you must use the same set of units. I don't know about you, but I prefer joules. And so I will convert 25.7 kilojoules per mole into joules per mole. Then my units will be the same and everything will work out very nicely. Any questions before I plug all of this in? Okay. So my delta H dissolving is 25.7 kilojoules. So I need to move my decimal point 3 places to the right, which will be 25,700 joules per mole. My moles dissolved, well, I don't know how many moles it is yet, but I have my grams, so it's going to be a molar mass question. I'll do my molar mass down here to give myself some space to work. See if I'm on screen. There we go. If only all of our next exam were gram to mole conversions, life would be good, but at least there will be some of them. Molar mass, I have 2 nitrogens. Plus 4 hydrogens plus 3 oxygens. I get 80.05. Grams of ammonium nitrate per 1 mole. (33.7) divided by 80.05. I get my moles of ammonium nitrate. I will now plug them in here. And you can see that my moles are canceling out, leaving me with just joules. And I didn't talk about this in the previous example, but Q is a heat, and heat will have units of joules. So we're happy that worked out. Now my mass is equal to my mass of my water plus my mass of my salt. I have volume of water, but I will ask you to remember that for water, it is density of 1.00 gram per milliliter, which means that this number is also my number of grams. So my mass is going to be 88.9 plus 33.7. So I get 122.6 grams. My specific heat capacity is going to be the specific heat capacity of water. I talked about that in the lecture outline. So the solution is mostly water. And while it's probably not perfect, it is a good assumption, and you may assume it. So this is the specific heat capacity of my water, joules per gram degree Celsius. And I don't know my final temperature, but my initial temperature is 20.6. And I did not need to create space there because I got it on the page. So the only thing we don't know is our final temperature yet again. It doesn't always have to be like that, but in these 2 examples it is. Multiplying everything out on, let's see, and my signs are all good. So on the left-hand side, it's going to be 25,700 plus 0.421. No. Try multiply. 25,700 times 0.421. I get 10,820 joules. I'm going to multiply just like I did before, multiply the first 2 numbers to get a TF term, then multiply times 20.6 to get a number term. So I get my minus sign. And I think I added again. I don't know what, let's see, try that again. I think I need a break too, but we're almost there. Times, there we go, 513 times T sub F minus minus, which is a plus, times the 20.6. 10,567. Technically, those are units of joules too, so we'll put them. So now I need to get this term by itself. I'm going to bring this 10,567 over to the other side. So on this side, it's going to be the difference between these two numbers. 10,820 minus 10,567. I get 253 equals minus 513 times TF. Divide both sides by minus 513. And my final temperature is minus 0.493 degrees Celsius. That's what you'd enter. And for this one, so yes, my chemical cold pack was able to take it from room temperature down to below freezing. And so that will keep your or my ankle cold so that the swelling won't will be minimized. Any questions about that one?